Alright, let's look at the practice exam 1, problem number 8. Alright, so we want to determine if this improper integral converges or diverges. Alright, so let's look at this integrand here. So you have a sine squared of x, right, over x times square root of x, right? So since x is between 1 and infinity, and so this quantity is definitely positive because sine has a square on it, right? Then since sine, the largest value sine can get is 1, so this guy is actually less than or equal to 1 over x square root of x. And we can actually rewrite that as 1 over x to the 3/2 power, right? Alright, so instead of working on the original somewhat complicated improper integral, we're going to work on this improper integral. Actually, I want to write it as x to the negative 3 over 2. Alright, so let's look at the improper integral from 1 to infinity. Then you have x to the negative 3/2 power with respect to x. Right, so first step would be I'm going to replace infinity by t. Right, then we take the limit. Right, t goes to infinity. Right, so you have x to the negative 3/2 power with respect to x. Right, so this is going to be equal to limit as t approaches infinity, right? Then antiderivative is going to be add 1, so you have x to the negative 1/2 divided by negative 1/2 is multiplied by negative 2, right? Then you're going from 1 to t, right? So this is going to be, we still have a limit as t approaches infinity, right? We put t in there, so it's going to be negative, right? So there's a 2 over, right, negative, so t is going to be on the bottom. 1/2 power is square root, right? So you have a minus with a negative sign, so it's going to be plus 2, right? Because plugging 1, it's going to be 1, so it's that. All right. Then you can see that this guy, as t approaches infinity, right, this guy, the first one approaches 0, right, because it's negative 2 divided by a really big number. It's going to be very close to 0. So what you get is 2, which is convergent. Right? So we looked at the larger one, which converges, right? Which means that the smaller one is going to be convergent. So you can just say by comparison, theorem, we may conclude that the integral from 1 to infinity sine squared of x over x times square root of x with respect to x is convergent or converges, right? So that's the answer to this question. But comparison theorem is very useful because we don't have to deal with sine squared of x when you evaluate the integral, right? That's it. I hope that this was clear.